Hello students, welcome to Siddhapur Mathematics Academy. So already in the applications of integrations, we started the area between the curve. Only one exercise we have because they are deleted some part. So here in the last class I stopped the area of the circle. Find the area of the circle by using integration. So with the next continuing to the next, find the area enclosed by the ellipse x square upon a square plus y square upon b square is equal to 1. See here, if you know the basic figure, at least basic simple figure related with the ellipse. If it is x square upon a square plus y square upon b square is equal to 1, the condition is not mentioned, means it is understood a is greater than b. That means the major axis is along x axis. The figure is like this. And already we are familiar. All the four parts are symmetric. If you calculate the area in the first quadrant and make it multiply with 4 times, you will get the area of the complete ellipse. Why we are doing like this? If you move like here on the left side, the answer will be negative. And if it is a lower limit and upper limit, positive and negative, means we have to move about the even and odd functions. Instead of that, here we can draw the perpendicular. And here the value of x is 0 and this value is a. X square upon a square plus y square upon b square. The vertices is a comma 0 and it is 0 comma b. So then what you are writing? Required area is equal to, I am giving you the solution. Required area is equal to shaded part as shown in the figure. So that is equal to 4 into area of AOB, correct? That is 4 into integration from 0 to a. Here lower limit x value is 0. It is, we are taking a area between the curve and the x axis. We are taking a area between, you can take a curve and the y axis also. At that time it is 0 to b. But I am taking a area between the curve and the x axis. So x values we have to write. Here x value is 0 and here x value is a. And you know that already we are familiar. In the last class I gave the important formula. If it is area between the curve and the x axis, it is from integration of the lower limit and upper limit y into dx. And see here, it is x square upon a square plus y square upon b square is equal to 1. What is y square upon b square? It is 1 minus x square upon a square. Next, y square upon b square is equal to a square minus x square upon a square. Y square is equal to b square upon a square, taking b square on that side, a square minus x square. And for my convenient, I wrote constant separate and with x one side. There is no place, that's why I am writing reverse. Y we can write taking a square root b upon a root of a square minus x square. Write down that value. It is 4 into integration from 0 to a b upon a root of a square minus x square into dx. 4 into b by a, it is a constant in the flower bracket. We are familiar with root of a square minus x square formula. This is x by 2 root of a square minus x square plus a square by 2 sine inverse of x by a from 0 to a. So I think this you wrote. So now I will rub this. I require the place. Now write down the upper limit and lower limit. It is 4b upon a. Upper limit is a. It is a by 2 root of a square minus a square plus a square by 2 sine inverse of a by a. First we have to write the upper limit. Minus, here x by 2. X is what? 0. 0 by 2 is 0. That means the complete value is 0. Plus a square by 2 into sine inverse of 0 by a. So we are familiar with all the calculations. Here a square minus a square is 0. Complete value is 0. and this remains as it is. This is 0. 0 upon A is 0. Sin inverse 0 is 0. So that value is also 0. Then what is remaining? The remaining value is 4b upon A in the flower bracket. This is 0 plus A square by 2. Sin inverse A by A get cancelled. Sin inverse 1 is remaining and the remaining values are 0. And what is the sin inverse of 1? Sin inverse of 1 is pi by 2. This 4 get cancels, 1a get cancels. It is pi ab square units. See, in area of the ellipse, x square upon a square plus y square upon b square is equal to 1 is pi ab. That gives you one important hint for your CET. For example, if it is the area between the curve x square by 16 plus y square by 9 is equal to 1, that is nothing but x square by 4 square plus y square by 3 square is equal to 1. Here a is 4, b is 3. Then what is the complete area? Complete area is pi ab, that is a is 4, b is 3. 4 3s are 12. 12 pi square units. This is completely purely for CET. Now moving to the next example. The question is from the exercise 8.1. Question number 4. Find the area of the region bounded by the ellipse x square upon 16. Yes, whatever I give, that same question we have. Plus y square by 9 is equal to 1. Already we are familiar by shortcut method, our CET method, but this question is for 5 marks in the theory. We have to solve it systematically. We have to solve it systematically. Already you are familiar with the answer, no doubt there. Here first x square upon 4 square plus y square upon 3 square is equal to 1. Now A is 4 means the vertices are 4, 0 and 0, 3. Write down as it is. Required area is equal to shaded part as shown in the figure. That is equal to 4 into area of AOB. I think no need to explain. Already you are familiar with the previous example. It is 4 into 0 to 4. Upper limit is 4. Y into dx. Now we have to write this. It is x square upon 16 plus y square upon 9 is equal to 1. Y square by 9 is equal to 1 minus x square by 16. So y square by 9 is equal to 16 minus x square upon 16, or y square is equal to 9 by 16, 16 minus x square. For our convenient, y is equal to 3 by 4 square root of 4 square minus x square. So it is 4 integration from 0 to 4, 3 by 4 root of 4 square minus x square into dx. This 4 get cancels, only 3 comes outside, and write on the integration. It is x by 2 root of 4 square minus x square plus a square. A square is 4 square by 2 sin inverse of x by 4 from 0 to 4. Write down the limits, upper limit and lower limit. 3 outside as it is in the flower bracket, 4 by 2 root of 4 square minus 4 square plus 4 square is 16, 16 by 2 is 8 plus sin inverse 4 by 4, and next minus 0 upon 2 is 0, so directly I am writing 0 plus 8 into sin inverse of 0. Yes. If you are thorough in the calculations, this value is 0. even this is 0 and sine inverse 0 is also 0. Write down the remaining value. Remaining values are 3, 8 into sine inverse of 1 because all the values are 0. 3 into 8 into sine inverse 1 is pi by 2. And already we are familiar with the result because of our hint. Now moving to the next question, question number 5. Here also we have same question. Find the area of the ellipse. Area enclosed by the ellipse. Question number 5 in 8.1. Find the area enclosed by the ellipse. X square upon 4 plus y square upon 9 is equal to 1. See here. Here A is less than B. X square by 2 square plus y square by 3 square is equal to 1. A is equal to 2, B is equal to 3. A is less than B means the figure is like this. Only difference is the major axis is on y axis and vertices are same. A is 2, 0, B is 0, 3. Here also I am taking the area between the curve and the x-axis, even though it is less, but the figure comes like this. Required area is equal to shaded part as shown in the figure, that is equal to 4 into area of AOB, that is equal to 4 into integration from 0 to 2 y into dx. I am writing y because I am taking a area between the curve and the x-axis. Now I am writing the calculations here. X square by 4 plus y square by 9 is equal to 1. Y square by 9 is equal to, this is 2 square minus x square by 2 square. 9 upon, if you want you can write 4 also. So y is equal to 3 by 2 root of 2 square minus x square. 4 into integration from 0 to 2, 3 by 2 root of 2 square minus x square into dx. It is 6. I am writing the formula. X by 2 root of 2 square minus x square plus 2 square by 2 sine inverse of x by 2. See, without integration also you know that what is the answer. The answer should be what? Pi AB, 6 pi. The required answer will be 6 pi. Because of shortcut method we are familiar. Now write down the upper limit and lower limit. 6 as it is 2 by 2 root of 2 square minus 2 square plus 2 into sine inverse of 2 by 2. This is the upper limit. Minus 0 into anything is 0 plus 2 into sine inverse of 0 by 2. Now we are familiar. 2 square minus 2 square is 0. Even this is 0 and this part is also 0. No need to write that part. It is 6 in the bracket 2 into sine inverse of 1. Remaining parts are 0. 2 into pi by 2. And already we are familiar. It is 6 pi square units. We know that it is pi AB. A is 2, B is 3. Moving to the next example. I am giving you all the examples in very simple steps. Question number 6. Find the area of the region area of the region in the first quadrant enclosed by x-axis, comma line x is equal to root 3y and the circle x square plus y square is equal to 4. See, if you are familiar with all the all the analytical geometry figure, it is very easy to write. See here, x square plus y square is equal to 4 means it is 2 square. For your information, I am writing this represents a circle with center origin and radius a. Then x is equal to root 3y, equation 2. If you are familiar completely with the basics, you know that it is in the form of y is equal to mx. Y is equal to mx is a straight line. Passing through origin comes in first and third quadrant. First and third quadrant, and here that means now you know that the line and the circle meets where they meets in the first and the third quadrant. First I will solve these two equations. I am writing x is equal to root 3y in this equation by solving 1 and 2. 1 is x square plus y square is equal to 2 square. X value is root 3y whole square plus y square is equal to 2 square. Square root and square, it is 3y square plus y square is equal to 4. Y square, 4y square is 4. Y square is 1. Y is equal to plus or minus 1. See, if y is 1, then x is equal to root 3 from equation 2. If y is minus 1, then x is equal to minus root 3. That means the points of intersection of circle and the line. The points of intersection of the circle and the line are root 3 comma 1 and minus root 3 comma minus 1. One is in the first quadrant and one is in the third quadrant. See, without figure, without calculation only I told with the help of basic knowledge. Now we have to draw the figure that gives you to write all the steps properly. See, already I gave, it is the equation of the circle with center, origin and radius what? Radius 2. And this is the line. This is root 3 comma 1 and this is minus root 3 comma minus 1. This is the line x is equal to root 3y and radius is what? Radius is 2. That means this is 2 comma 0. This is 0 comma 2. That means from here to here the distance is 2. This is the origin. Let us take this as A, this is B. And remaining points keep as it is. See, you know that when you are finding the area, now we have to find the area of the region in the first quadrant, where the line and the circle meets. That means this shaded part is what? Required area. Line and the circle in the first quadrant. But you cannot calculate it directly. Why? In 1/2, if you are finding the area between the curve and line, whatever with the x-axis, it is a line and it is a curve. One is a line and one is a curve. So, two different parts are there. That's why where they meet, from that you draw the perpendicular. This is the perpendicular. From where it is a perpendicular? At x is equal to √3. See, from 0 to √3 we have the line and the x-axis. From 0 to √3 where I draw the perpendicular. So, 0 to √3 mele enite line, and √3 to 2 what it is? It is a curve and the x-axis. Then what you are writing? I am calling this as a C. Required area is equal to shaded part as shown in the figure. Next, it is area of OACO, OABCO, that is equal to area of, now complete. Why we are not taking complete? Because one is a straight line, one is a curve, we cannot write completely, that's why we are dividing. Area of OACO, that, see, only we have the straight line, plus area of ABCA, here we have the curve and the x-axis, and here it is a perpendicular, and on the other side it crosses x-axis. Now, how you write the limit? 0 to √3. See, it is in between the line and the x-axis. That's why y into dx. Y from what? From the line. Y from the line into dx plus √3 to 2. Here also we are writing, but y from the circle. From the circle into dx. Yes, what is the line? What is the line? Line is x is equal to √3y. Then what is y? 0 to √3. It is x by √3 into dx. See here, y is x by √3 plus √3 to 2. What is the y from this equation? Root of 2 square minus x square into dx. If you want, I will write here. X square plus y square is equal to 4. Y square is 4 minus x square. Y is equal to root of 4. We can write 2 square minus x square. Now go for the integration. It is a simple integration. It is very simple integration, and explanation also I gave in very simple language, in simple steps. 1 by √3 constant, integration of x is x square by 2, it is from 0 to √3, plus it is normal, x by 2 root of 2 square minus x square plus a square. A square means 2 square. 2 square by 2 sin inverse of x by 2 from √3 to 1 by 2 √3 outside, it is √3 square minus 0 plus, first I am writing upper limit. Now I am writing lower limit. Lower limit is not 0. In the previous it is 0. So we wrote the values directly. It is √3. √3 by 2 root of 2 square minus √3 square plus 2 into sin inverse of √3 by 2. Yes. Here 1 upon 2 √3 into 3. Square root and square get cancels. 2 and 2 get cancels. This value is 0. 2 square minus 2 square. This value is 0. 0 plus 2 into sin inverse 1 minus root 3 by 2, because 2 square is 4, 4 minus 3 1, and it is minus, taking minus inside, minus 2 into sin inverse root 3 by 2 is what? 60 degree. 60 degree is pi by 3. Yes. 3 we can write as root 3 into root 3 upon 2 root 3 plus 2 into pi by 2 minus root 3 by 2 minus 2 pi by 3. See here, it is root 3 by 2 plus pi minus root 3 by 2 minus 2 pi by 3. Minus root 3 by 2 plus root 3 by 2 get cancels. Pi minus 2 pi by 3. After taking a LCM, you will get pi by 3. Pi by 3 square units. Yes. Moving to the next question. If you are able to draw the rough figure, that shaded part is must and should. Moving to the next question, that is question number 7. Find the area of the smallest part find the area of the smallest part of the circle x square plus y square is equal to a square, cut off by the line x is equal to a by root 2. See, already you are familiar, x square upon x square plus y square is equal to a square is the equation of the circle. This is the equation of the circle with the center, origin and radius a. And radius is a. Next, the line is x is equal to a by root 2. Obviously, it is less than a or what? So, somewhere here rough figure, x is equal to a by root 2, because radius is a comma 0 and this is 0. Let us call this as a, b, c and this is d. We have to find the smallest area. When you observe this, we have two parts. One part is this part, a, b, c, complete this part, another part one this. So, when let us call, if you want you can call it as a E. A, B, C, E, A, one part, and A, B, C, D, A, another part. Which part is the smaller part? So, this side, whatever I am giving you the shaded part, that part is the smallest part. And our question is find the area of the smallest part. And what is the, where we did the perpendicular? The perpendicular is a by root 2 and here it crosses the x axis. Write down. Required area is equal to shaded part as shown in the figure. And why we are shading that? Because we required the smallest part. That is equal to area of A, B, C, D, A. And below x we cannot come. That's why we can write 2 into area of A, B, D, A. We can write 2 into area of A, B, D, A. That is 2 into here, which is a line a by root 2. Lower limit is a by root 2, upper limit is a, because the radius is a. Y into dx. This is nothing but area between the curve and the x axis. Y curve is nothing but in this figure it is a circle. So, we have to write y value from the circle. What is y value from the circle? It is 2 a by root 2 to a. Y is root of a square minus x square into dx. 2 into in the bracket x by 2 root of a square minus x square plus a square by 2 sine inverse of x by a from a by root 2 to a, and write down that values. Now we wrote the integration, write down the values. Upper limit is a, lower limit is a by root 2. 2 outside as it is, a by 2 root of a square minus a square plus a square by 2 sine inverse of a by a, upper limit, minus, there is no place, I am writing lower limit here. In place of x, a by root 2 upon 2 root of a square minus a by root 2 whole square plus a square by 2 sine inverse a by root 2 upon a. Write it in the bracket because outside we have a minus. Here a get cancels. First this value is 0. 2 in the bracket 0 plus a square by 2 sine inverse 1 is pi by 2 minus, take minus inside, it is a upon 2 root 2, and here a square minus 2, it is 2a square minus a square, at the same time I took the LCM, plus a square by 2, a and a get cancelled, so 1 by root 2, 1 by root 2 is pi by 4, this is also minus because outside we have a minus. Now simplify this. It is 2 a square pi upon 4 minus a by 2 root 2. 2a square minus a square is a square. Square root of a square is a. A by root 2 minus a square pi by 8. See next one. Here 2 as it is, a square pi by 4 minus a square by 4, root 2 into root 2 is 2, minus a square pi by 8. So here first and the last term I have a pi, middle term we don't have a pi. 2 into LCM is 8, it is 2a square pi minus 2a square minus a square pi. 2 1s are 2 4s are 1 by 4 outside, 2a square pi minus a square pi is a square pi minus 2a square. If you want you can take a square also outside, a square by 4 in the bracket pi minus 2 square units. This is the area of the smallest part. Moving to the next question. Next one is important question. Next one is the important question. Find the value of A here. Write down the question. The area between the question number 8, the area between x is equal to y square and x is equal to 4 is divided into two equal parts. Two equal parts by the line x is equal to a. Find the value of a. Find the value of a. See, first if you are familiar with the figure, then only you can draw, no? Then only you can write the area. X is equal to y square is what? It is a parabola, opens in the positive direction of x axis. Opens in the positive direction of x axis. And the area between the parabola and the line. The line is x is equal to 4. is divided into two equal parts by the line x is equal to a. This is the line x is equal to a. It is divided the area into two equal parts. That means what is given? Given area of ABCOA. See here, ABCOA is equal to area of ABCFEDA, this part. But instead of taking this, we can take 2 into area of ABOA only in the upper part. That means in first quadrant. 2 into ABEDA. Both the sides A get cancels. We can write area of ABOA is equal to area of ABEDA. So here this part means from 0 to A, because this line is A. It is 0 to A. This is also y into dx, because it is area between the x-axis and the curve. And the next one is A to 4. Understood? It is A to 4 y into dx. Both we are writing from the same curve. 0 to A root x into dx plus A to 4 root x into dx. And they cannot get cancelled because their limits are different. Understood? Their limits are different. Integrate. X raised to 1 by 2 plus 1 upon 1 by 2 plus 1 from 0 to A. Here also x raised to 1 by 2 plus 1 upon 1 by 2 plus 1, same. It is A to 4. Now both the sides 1 by 2 plus 1, 1 by 2 plus 1 get cancels. X raised to 3 by 2 from 0 to A. This is also x raised to 3 by 2, but the limits are A to 4. Now substitute the values. It is A raised to 3 by 2 minus 0, 4 raised to 3 by 2 minus A raised to 3 by 2. Take minus A raised to 3 by 2 on this side. And 4 is written as 2 square. Yes, it is 2 into A raised to 3 by 2, it is 8. Then what is A raised to 3 by 2? A raised to 3 by 2 is 4. But we required only A, means rising both the sides 2 by 3. So this implies A is equal to 4 raised to 2 by 3. This is the value of A. In the next class, I am giving you few more examples, and don't miss these videos, because definite 5 marks you will get, and they are very simple.